So let me just test this one out. One moment. Yep. Good. Well, first of all, can everybody hear me? Are you there? Great. Thanks. Good morning and welcome to the DB Grand Conference. It's a pleasure to be here presenting to the IT industry in Korea. My presentation is going to be a lot less technical than the previous presentation. And I know everyone here knows quite a bit about databases and data. And the other thing that I'd like to tell you is that the books that you have in front of you, the presentation that's in there printed is going to be quite different than what I'm going to show you today. So last night I made a bunch of changes. So thank you, the organizers, for accommodating the changes. And if you'd like to get the updated versions of the presentation, please stop by at the ALTIBASE booth. We'd be more than happy to email you a copy. My presentation topic is continuous data processing. And when we talk about continuous data processing means one thing more than everything else. It means real time. And real time is all about now. Real time means doing things right now instead of doing them tomorrow. Real time means doing something else tomorrow because you could do something yesterday. So real time enables us to do a lot more. So I'm going to start with a story. I'm sure you can all read the slide here. In the last 20 years, we started talking about seconds, then went to milliseconds, then to nanoseconds. And this is a quote from 1980. And I'm sure a lot of people here remember 1980, but just like the people who were on stage a little earlier, some of you were probably pretty young to barely remember 1980. In 1996, let me tell you my story. In 1996, I walked into a bar in New York City. I was in my mid-20s. I sat down and there was an old man sitting next to me. He looked like he might be about 80 years old. I started talking to him. I asked him, "What do you do?" And he said, "I'm retired." So I said, "What did you do before you retire?" He said, he wrote contracts at an investment bank. So I couldn't quite understand. He said, in the 1950s, 1960s, when one company bought another company, there was a master contract. And for everyone to get a copy, my job was to sit down and write a copy of that contract. So I asked him, "How many pages did you write every day?" He said, "About 25. Today, the photocopy machine in my office copies about 100 pages in 1 minute. So in 1950s, the amount of work that he did in an entire day can be done in 15 seconds in 2010. So times have changed. So if you look at the compression of time, the math, and this is all enabled by real-time technology, 1 millisecond means 1 million nanoseconds, right? If you start to work at age 22 and you retire at age 62, that's 40 years, which means 480 months, 2016 weeks, 80,000 plus hours, 4.5 million or 4.8 million minutes. And you divide that by a million, which is the difference between a nanosecond and a millisecond. An entire lifetime of work for someone who lived in the 1920s, 1930s can be done in a matter of minutes in this age. And that's all enabled by real time. That's not the only example. Let's look at New York Stock Exchange. Does everyone know what New York Stock Exchange is? You know, you have KoStack here. And New York Stock Exchange is the one of the world's oldest and largest stock exchanges. And remember, fundamentally, computing technology is all about processing data into information. And by turning data into information, IT improves productivity, quality of the services that we provide. It reduces the human error, automates many of the manual tasks, and allows us to do our business better, faster, and more cost-effectively. And innovation is when you have a new technology come around and make a sometimes radical, sometimes significant change to the way that we do business. And real-time technologies have radically changed the way that we do business and the economics of our businesses. From the telegraph in the 1840s to the telephone, the number of shares traded in on New York Stock Exchange multiplied by 1,000 times. They used to use a 500 character per second ticker, and they moved to 900 character ticker, and that grew the number of shares traded 400%. Over the years, what ended up happening is we introduced much faster computers, much faster communication frameworks, and much better technology, which has changed the amount of work or number of shares traded in a day exponentially. Real time allows us to do a lot more work, and it allows us to do a lot more now. That's the economic value of real-time technology. That's the economic value of continuous technology. During this 30-minute presentation, while you're sitting here, the number of shares that will be traded on New York Stock Exchange is going to be more than the entire year of 1960. So you can do the math. Now, in IT, the reason that we implement technology is because we love technology, right? But that's not why the business wants us to implement technology. Business doesn't want IT to implement technology because it's cool. Business wants IT to implement technology because of market drivers, because of outside world pressures, because of different business requirements. When you look at these market drivers, customers today have a lot less patience. If they come to your website or if they come to your store and if they don't get the service, they can immediately go to another website or another store or your competition. Customers want things to be accessible all the time. 10 years ago, you wouldn't call a travel agent at 3 in the morning and expect an answer. But today, at 2 in the morning or 3 in the morning, you can go online and buy a plane ticket. That means accessibility 24/7, 365. Customers want accurate information, and customers want the companies to be accountable. If you lose your customers' information, or if the information you provide to your customer is inaccurate, again, they go to your competition. Customers have a lot more choices. Now we have savvy customers. You cannot sell the same thing for twice the price just because the customers don't know the price, because they can take out their smartphone and check the price on the spot, even in your store. So business intelligence has to be a lot more improved, and you have to do your reporting continuously so that if your competition changes their prices, you know about it immediately. And of course, consumer skepticism, regulatory climate, the previous presentation mentioned those topics pretty extensively, so I'm not going to go into that. Now, in English we say the customer is king, and earlier I was talking to our translator. If you're listening to the Korean version, she told me that you have the exact same phrase. Ultimately, customer is the king. If you work for the government, it is the people that you provide service for. If you work at a university, it's the students. And if you work in the commercial world, it's your customers. And at the end of the day, customer experience is the biggest driver behind everything that we do. Computer technology allows us to extend our reach to new markets, to new customers, and a wider audience in a cost-effective fashion. Now, many Korean companies have done this very successfully. I live in California, and my washing machine is LG, my television is Samsung. That means that LG and Samsung have broken that reach and have extended themselves into these international markets. And that's the biggest driver behind today's growth economy. Now, the customer experience has essentially two concepts. One of them is reach, and the other one is richness. When we talk about reach, we're talking about bandwidth, customization, and interactivity. Now, bandwidth requires computing power and communication power. Customization requires historic knowledge. What did this customer do with me before? That's the business intelligence, historic information. And interactivity requires real-time intelligence and real-time business analytics and continuous processing. Now, richness is all about information. Interactive richness is all about real-time information. On the other hand, when you're talking about reach, meaning how many customers can I get to, that is, about the number of customers I'm trying to reach and the geographic diversity. In Korea, you're lucky that a substantial number of the technology companies are surrounding Seoul. But when you look at a market like United States, we're talking about much bigger geographic distances. So a salesperson in California cannot easily go to a customer in New York. That's 5-6 hours of flying. Now, reach requires, from a technology perspective, scalability and also 24/7 global operations, because you have to be always accessible when you're serving multiple geographies. And ultimately, you have to provide that real-time access. Traditionally, there has been a trade-off between the richness and the reach of customer interaction. But given the limited number of resources and the extent of our reach and the quality of our interactions, for the same cost, we may be able to reach different people in different ways. And for example, for the same price, you can hire a salesperson, a sales executive, and that person can build relationships with maybe 12 customers in 1 year. You can, with that same money, instead of a salesperson, you can get a call center. And that call center may get to 100 customers in a year. It wouldn't be as interactive, it wouldn't be as rich of a communication. You can set up a website, and with some level of interactivity, you can reach thousands of people. But if you want to do it even cheaper, you can get a lot of catalogs printed and mail it to all these people and get to 1 million people instead of the 12 people that one sales guy can reach to. But there is a big difference between human interaction and catalog. On one side, you have a very rich interaction. It is high bandwidth, it's face-to-face, there's a lot of information exchanged. It's highly customized, has a personal touch, it's interactive, and there's a dialogue. But it only reaches to a few people, because if you want to get to many more, it will get very expensive. On the other end of the spectrum, the catalog, it's not interactive, it's barely customized. The only thing that's personalized on it is your name and address if it was mailed to you. It is a very low bandwidth communication, but it reaches out to many more people at a little cost. In the New World Order, we have to break that trade-off between reach and richness, and that's the economic value of real-time, because it's the real-time technology and continuous data processing that allows us to make sure that information and that interaction is empowered by technology where it is needed and when it's needed. It's about making information and service available to a wider audience in an efficient and cost-effective fashion. That's the economic value of technology innovation, that's the economic value of continuous data processing, and that's the economic value of real-time data. So this slide is a slide that has been around for a long time. This is how most IT systems operate. There's a business event, you capture that data, that information gets delivered, and then you take action. So let me give you an example. I call my travel agent, and I say I want to book a flight between California and Korea. At that point, if the travel agent has information about my preferences, knows my hotel or knows my other information, she can come back and say, the hotel that you like to stay is running a campaign. Would you like me to book a flight right now, a hotel room for you right now? At that point, I'm likely to say yes. However, if the travel agent calls me the next day and says, by the way, did you need a hotel room? I may or may not answer the phone. I may or may not say yes. Probably I booked the hotel room on Expedia or some other place already. So the business event is me calling the travel agent. The data captured is travel agent finding out that I'm going from SFO to ICN, the flight. That information has to be continuously and in real time analyzed, and an action needs to be taken. And that action is make me an offer for the hotel room. And the value, the business value of the information, if you process it continuously and in real time, goes up significantly as opposed to if you do the processing a day later or 3 days later. Now let's talk about the changing world of data. The data volumes have been exploding. How many people here have large databases? Can you just show me hands? Is anybody here? Anybody awake? Any large databases? Nobody has large databases in this room? No? Okay. Well, if you ask people who run large databases or who run IT infrastructures, you'll hear that they're running larger and larger databases, and there's more and more data. In the meantime, the data has less and less structure. One of the things that you may have heard of recently is that HP acquired a company called Autonomy, which deals entirely with unstructured data. And to make sense of the unstructured data, these days we use metadata, and we have terabytes of metadata alone, not just data. There's also massive parallelization going on. There's a lot of commodity hardware, appliances, there is all the other technologies that are emerging. But in the database world, the two key areas that we're really interested in are OLAP and OLTP. And what's the line between OLAP and OLTP in the real-time world? Now, let's look at the characteristics of these operational versus analytical systems. When you look at analytical systems, you'll see that there is large bandwidth, customization, and scalability. You use these systems for data warehouses, data marts, reporting applications, and in the typical OLAP environment, you have few users, batch updates. They're used for strategic purposes. And you have terabytes of data, and these systems are relatively important. When you look at the operational systems, they support many users, they process a lot of transactions, but the operations are much smaller, and the data sets are much smaller. And they ensure that business operates from a tactical perspective. These are typically real-time systems, and they're not just important, they're mission critical. Today, the lines between the OLTP systems and OLAP systems are getting really blurred. And that's because operational analytics is the biggest driver behind it. And operational analytics is also known as pervasive analytics, active intelligence, or continuous analytics. And it's all about being able to process real-time data continuously. When you look at operational analytics, what ends up happening is that you're going to start seeing these systems need to support many more users. They require continuous and real-time data coming in. Not only do they support strategic operations, but they're used for tactical operations. There is mixed workload, meaning not just long and big queries, but also short transactions as well. The data volumes are significantly larger. And these systems are not just important, they're mission critical. If an operational analytics system or a continuous analytics system goes down, the business gets impacted. And when you look at it from a real-time perspective, real-time access to real-time information is the key enabler. So without real-time or without continuous processing, you cannot enable operational analytics. Now, when you look at OLAP and OLTP, many database vendors will argue that we should have one database that contains all the information. Can one database do everything for analytics and transaction processing and all these different purposes? People have tried, but they have not quite been successful. In the world of real-time, what's more important is to understand the value of, time value of data, rather than trying to make your database do all these different things at the same time. One database can do everything for everyone when pigs fly. Now, when we look at the value of data or time value of data, there are two key things to keep in mind. One of them is what we call the persisted value of data. And handling persisted data is different than handling temporal data. When you look at persisted value, data is valuable sometime in the future. So if I ask my database, what did Kim buy in May of 2011? That data was stored in May of 2011, and today in October, it has some value. Or how many bottles of milk my store is going to sell this week? That data has been stored over time, and it has some value right now. Now, temporal data, on the other hand, has different characteristics. It is valuable right now, but it may not be valuable in 5 minutes. The GPS coordinates of my cell phone, if I'm running a mapping application, is not important in 5 minutes. What is Kim looking at on my website right now so that I can give a special offer to her is relevant right now, but what did she look at on my website 5 minutes ago is not really that important. All I really need to know is she was on my website. So being able to separate the persisted value and the temporal value of data is the precursor to understanding the future of the data framework for continuous data processing. What is the biggest difference between persistent data and temporal data? Persistent data, you store it on disk usually, then you analyze it, and then you summarize it, and you use it. Temporal data, you analyze it first, then you create a summary of it, and then you store what is relevant for the future. This is a very big fundamental architectural difference. Store, analyze, summarize versus analyze, summarize, store. So you can look at this as the two states of data for continuous data processing. And you need to enable real-time access to persistent data, which we call data at rest. And you need to provide real-time access to temporal data, which is data in motion, while the data is still moving before I stored it. And ALTIBASE has delivered the innovation of both real-time data at rest and real-time data in motion solutions. With our two products, ALTIBASE HDB, the hybrid database, we have a real-time solution for data at rest. And with ALTIBASE DSM, we do have a solution for data in motion. I'm not going to go into too much detail about the products because we do have some ALTIBASE people in the booth outside, and if you have questions about the products, they can answer your questions in a lot more detail. But ALTIBASE HDB is an ACID-compliant relational database, and it can be deployed as an in-memory database, on-disk database, or as a hybrid database. The key characteristic for real-time is, of course, performance. The second key differentiation for ALTIBASE HDB in a world where the data volumes are exploding is that we don't have the data size constraints of traditional in-memory databases. You can store data on disk, or you can store data in memory. It is full SQL 92 compliant implementation, a very feature-rich solution database with functions, triggers, PLSQL, multi-version concurrency control, everything that you expect from a very mature database. And last but not least, to provide that real-time accessibility and continuous availability, we do have pretty sophisticated high availability features. So it is appropriate for use in mission-critical systems. And there are quite a few people who have deployed ALTIBASE HDB in mission-critical environments. And ALTIBASE HDB is the real-time access to real-time data at rest. The other product that ALTIBASE offers today is ALTIBASE DSM, and DSM stands for Data Stream Middleware. ALTIBASE DSM combines complex event processing, continuous query language, distributed table cache, and a data distribution service, so that while the data is still in flight, while it's going from one system to another, you can analyze it before you even have to store it. This allows you to reduce the latency and deliver significantly faster real-time solutions as your data volumes grow exponentially. And ALTIBASE DSM is our solution, our real-time access solution to real-time data that's in motion. Now, our solutions have not come about because our engineers like to build cool technology. Just like, as I said earlier, IT departments want to build cool things, but it's always driven by customers, and it's always driven by market requirements. We do have many, many customers out there, many of them in Korea. I'm sure some of you are in the room, that have provided us the feedback and the direction and their requirements in order for us to build the real-time solutions that we provide today for both data in motion and data at rest. So I'd like to say thank you to our customers. And with that, I'd like to say thank you. Just one thing to remember, when you're dealing with real-time and when you're dealing with real-time technologies, good enough is the enemy of the best. Don't go for, okay, it's good enough. Always go for the best. Thank you.